Hey everyone, Chef Machine here. Today we're going to be talking about selection sort, and as always I'm going to be using Visual Studio Community on the Mac and C# to implement these algorithms. So let's jump right in. So we're going to be looking at selection sort. Selection sort is a sorting algorithm that basically takes in unsorted regions. It is, in my opinion, a simple and most intuitive sorting algorithm that exists out there. The idea of the algorithm is that it moves through the unsorted and sorted sections and moves items from unsorted portion to the sorted portion until the list is fully sorted. The runtime complexity of this algorithm is O(n) squared because it involves two nested loops. And auxiliary space complexity is O(1) since it only uses the input array and the items are sorted inputs. It's largely used when memory is a concern. So here's an example. This one actually matches the CX50 explanation, which you can find here and in the links in the description. So an example is we have an array that's given to us, an input array of 23, 42, 4, 16, 8, and 15. So we originally considered the whole array to be unsorted, and on pass 1, we're going to try to find a minimum element in the unsorted region of the array, which is 4. So we have the algorithm that kind of looks at as 23. Okay, we'll assume that we'll set minimum index to be 0, of which the output is 23. Then we continue to move along, and let's just say we reach 4. And we say, okay, well the minimum is actually 4, and so what we're going to do is we're going to go ahead and swap 4 and 23. So if you think of little arrows that go between 4 and 23, they're going to go ahead and swap the two numbers. So just like it says here, find the minimum number in the unsorted array, which is 4. Move it to the sorted portion of the list, swapping the element at 0 with the smallest element. So basically now, on pass 2, we're going to see the array look something like this. We have a sorted portion where we have 4. So again, 4 and 23 were 2. And again, 4 and 23 were swapped, so 23, 16, 8, and 15. Next step, just like the step before, we find the minimum number in the unsorted portion of the array. So again, this is now our unsorted portion. And in this portion, 8 is the smallest number. We swap 8 and the first element in the unsorted portion of the array will be swapped. And then we move over the sorted portion. So pass 3, we have 4 and 8, just like we said before. And 8 and 42 were swapped. So the next one is 23, 16. Again, 8 and 42 were swapped. So 42, 15. Now we have 15 as the smallest element. We move it into the sorted section, right, by swapping it with 23. So 15 and 23 were swapped. So now we have 4, 8, 15, 16, 42. And remember, 15 and 23 were swapped. So now it's 23 in the end. So what is now the smallest item in the unsorted section? It's 16. So for pass 5, we have 4, 8, 15, 16, okay, 42 and 23. Remember that 16, we actually didn't need to swap with anything because 16 was already in its correct location. So basically the swap didn't need to happen. And we'll see how that actually happens in the code slightly later. So for the next one, we have pass 6, which is 4, 8, 15, 16, 23, and again, we swap 23 and 42, so now we have 23, then 42. So now our unsorted section is only one element, so there's no need to go any further. So basically, we're done. Then here I always have, and again, these will be in the description, we have the CS50 out of Stanford explanation, then we have a My Code School explanation, we have selection sort explanation from Geeks for Geeks, and a written explanation from Geeks for Geeks. Alright, so let's take a look at the actual implementation. So the implementation is once again done in C# as I always do. So instead of run, think of it as SelectionSort.cs. So this is basically the selection sort function. So first what we're going to do is we're going to set the length, right? This is just to make my life a little bit easier, so I don't have to call input array.length every time. So our next step is to basically set up our first for loop, and that for loop is going to keep track of the unsorted region. So we set lowest index to I, and so what that is, it sets up um, the first element in the unsorted region. So if you think about swapping later down the road, we want to know which element to swap with, and we always swap with the first element in the unsorted region. And so this I, as the sorted region grows, will always represent the first element in the unsorted region. And so originally assume that the index of the lowest item in the unsorted region is that first item in the unsorted region. Then we start iterating through the rest of the unsorted region, which is why here in the second for loop, our j starts with I plus 1. So if you think about the array here at the top, we can see that we started off at 0, but then on our second pass, we started with I plus 1. So we started looking at these numbers to see, okay, well, which one is the smallest there? So we continue here through the loop, and we say, okay, if the value of the array at j, which again is our pointer in the unsorted region, is less than the value of input array at the lowest item index, which again is the first element in the unsorted region, then we say the index is actually j. So this is the loop that finds the lowest number, so we can actually rewrite this. So this is the loop that finds the lowest number in the sorted, let's just say element in the unsorted array, or unsorted region of the array. Right? So once we found it, original for loop, we do the swap, and this basically represents the swap. It says, okay, if the lowest item index is not equal to I, right, we do the swap. So we create a temporary variable where we store the value of the input array at index lowest item index. Then we set the lowest item index to the value of the input array at I, which again, remember, input array at I is our first element in the unsorted region. So we say the lowest element in the unsorted region now swaps with the first element in swap. And then obviously we also need to have a value at I, right, which is our temporary variable. So I being that first element is now the lowest element. So that does our sort. And so then we continue on here, and of course we could optimize it by saying length -1, and then we write out the items. So that's basically it for selection sort. Thank you very much for this helps. Bye.